Today we have something far beyond just a motherboard review, a motherboard overview of the ASRock Creator WRX80. You can actually learn a few things about Threadripper Pro if you stick with me through the whole video. We'll go over, using this as a platform if you're going to build a system based around a, $2,500 to $6,500 CPU, why this might be the appropriate chariot for it and all that. But this motherboard is unique in the market in a number of ways, not the least of which is that it's an enthusiast motherboard. Yeah, it has overclocking features and other features that you wouldn't expect on a pro grade motherboard. We have been wishing for these for several generations. People come into the chat and on the Level 1 forums and say, gosh darn it, why can't we have a motherboard that has literally everything? This motherboard literally has everything. There's a couple things we'll talk about where it would be nice to have even more, but it's not bad. We'll talk about that. Let's take a look at the board first. So what we're working with on this is the WRX80 chipset that is designed for Threadripper Pro 3000 and 5000 series CPUs. Though if you're watching this video in 2022, probably you're considering this for a Threadripper 5000 CPU. I think that would be my recommendation because, oh boy, they're fast. They're actually pretty much unchallenged in the market at the time that I'm making this, and this is a perfectly reasonable motherboard to run, 32 core, 64 core, not a problem. Now, when you look at this motherboard, it looks kind of like a server motherboard. When you go through the BIOS, it looks kind of like a server motherboard. When you look at the onboard stuff, it looks kind of like a server motherboard. And yet, it's perfectly at home being a workstation motherboard. It's got good onboard audio, it's got a good mix of onboard peripherals, but this thing is kind of a monster, and I wanted to tell you that because you could use this as the platform for a server. There's still a place for EPYC, don't get me wrong. EPYC is good for 24/7 stability and all that kind of stuff, but for a small work group of programmers, 8, 10, 12, 16 people that need a build server or an integration server or something at the edge, you can use Threadripper Pro to get, 3.5 nines, 4 nines, maybe not the 5 nines of EPYC, but a lot of nines in terms of stability and reliability, that uptime, the 99.99% guarantee, that's what I'm talking about. And still use this in kind of a server, kind of a workstation capacity. This kind of a machine is actually really popular among developers. The developers might only have 4 or 8 core individual machines, but then when they do the git commit or they push it up to the build server, then this thing actually does the building. And it's crazy to pay for something like this in the cloud when everything is pretty ephemeral. You might have your backups and stuff replicate to the cloud, or this is just an intermediate server for like the final build server that's on GitHub or maybe your GitHub Enterprise or something. But this makes a good platform to do your integration testing and your load testing and launching a billion instances of Chromium to do simulation or launching a billion instances of GCC to compile something. And so we see more and more people using platforms like this because of the high clock speed and lower cost, typically somewhat lower cost than EPYC in order to get the job done. With the price increases for the 5000 series of Threadripper Pro, they're not quite as cheap as they used to be in the 3000 series, so 3000 series may still be appropriate depending on what it is that you're building, and this is a perfectly fine motherboard to be able to do that. Let's take a look at the motherboard features and layout, and then we'll talk about more about the whys and the hows and the build. So this motherboard layout is pretty crazy. There's 5 PCIe Gen 4 X16 slots with steel reinforcement, but we actually have 7 slots in total. This is an eATX layout, so it's not really asking too much in terms of the case that you can put it in and the overall layout and the features and that sort of thing. This is a 14-layer PCB, so that's kind of like the higher-end server PCBs. It pretty much has to be in order to cram everything in here, and also with the memory. The memory is through-hole, through the circuit board, but really with Threadripper Pro, my recommendation for Threadripper Pro is registered error correcting 3200. Don't deviate from the JEDEC specifications. This board, it can do it. It's overclock rated up to 4533, so you could run unregistered error correcting memory, or you could run desktop memory at 3600. That is entirely a possibility. It's tested, it works, it's fine. But I think if you're going for the workstation 24-ish, 7-ish use case, you go for the error correcting memory in 3200. You don't need to push the platform in that way. I mean, you could if you're going for a world record, but you don't really need to do that. But this motherboard does support literally everything, and be sure to check out our memory video, which is almost out on the memory support on WRX80 specifically, because there's some really interesting stuff in terms of how that does that. Now this is 8 channel, unlike Threadripper, the TRX40, the previous generation, it was quad channel. This is 8 channels. There's 8 DIMMs, you put 8 DIMMs in 8 channels, and it's twice as fast as 4 channel. So if what you're doing is memory intensive, you can populate all the memory slots, and you should. Threadripper Pro supports 4, 6, and 8 DIMMs for reasonable performance configurations. That's something we talk about more in the memory video. That's nothing specific to this motherboard. That's just the Threadripper Pro platform. Something to keep in mind when you're configuring it. My recommendation, if you're building something for speed, go for all 8 DIMMs. Don't 4 now and 4 later. You're just setting yourself up for trouble. Just go for 8 DIMMs. JEDEC 3200 registered error correcting memory. You can do 3D stack DIMMs and load reduced DIMMs. BIOS support for those is stabilizing. I tested this with 512 gigabytes of registered error correcting DDR4, which is the maximum capacity that you can use before you get into somewhat slower load reduced DIMMs or 3D stack DIMMs. Again, just something to keep in mind. This has onboard Wi-Fi 6E 802.11ax and a movable Wi-Fi antenna. Not the rubber duck stuff. It's good. It's good Wi-Fi antenna. At the rear panel, we have the clear CMOS reset button, which I think should be a little bit more recessed, and onboard VGA. Now let's talk about the remote management thing for a second while we talk about, the VGA port. Why is there a VGA port on the motherboard? For remote management, this is standard for servers. When you remotely manage the server, in order to see what's on the display, the remote management interface has to be able to climb into the display memory and see what's actually being displayed. When it's an onboard VGA adapter, they're cheating. The ASpeed 2500 provides a VGA adapter that shows up to the host system as the simplest PCIe card in the world that's a VGA interface. But for the remote management controller, it's able to sort of scrape the contents of memory there and display it to you in a web browser remotely. So you can manage this system. If you don't want to use the onboard VGA, sometimes it does actually cause problems with the bar space and machine learning and that kind of thing. You can disable the VGA, you lose the remote video console capability, but you can still have the remote management. And in that case, it also supports a remote serial port management. You can tell your operating system to run a terminal on a serial port, and so even if the network is down and messed up, if you have the remote management interface, you can still log into your host operating system through the serial interface, which is like the remote management card has a serial cable connected to the motherboard that can talk to the host operating system. You can even manage when you leave BIOS via the serial interface, because Grub and a lot of other bootloaders, a lot of enterprise class bootloaders will support the serial interface just fine. So it's pretty cool stuff that there's onboard VGA. It really is. If you're looking at this saying, why is a 25, 30-year-old port on this motherboard? Well, hopefully now you know. We have our dual antenna ports and our dual Thunderbolt 4 ports. Yes, that's 40 gigabits per second. We've got another 2 USB 3.2 Gen 2 ports, our remote management gigabit port, our dual Intel X710 10 gigabit per second Ethernet ports, and then we've got our audio solution, including an optical SPDIF output. That is Nahimic audio, 7.1 channel audio, with the Realtek 4050H plus the ALC 1220. So this is a pretty elaborate audio solution for a workstation class motherboard. If you're doing game development, that may be something attractive to you if you're looking for, not having to have an add-in PCI card. Of course, with 7 PCIe slots, just put a card in. What are you worried about? The front USB-C port is a 10 gigabit front USB port. On board, it has 8 SATA 3, 1 Hyper M.2, that's PCIe Gen 4x4, 1 Hyper M.2, PCIe Gen by 4 and SATA 3 port, and 1 U.2. So 2 on board M.2. Now I'm using this with a 32-core 5975 WX processor. I think that's a really good fit for this board. Yes, you can run the 64-core, but I sort of skipped over the power delivery part, and now we can talk a little bit more about the power delivery aspect. Now, if you notice on this motherboard, we have 2 8-pin power connectors at the top edge of the motherboard for CPU power, auxiliary 12-volt, that's cool. But we also have an extra 6-pin 12-volt power connector at the front edge of the board. You will want to connect that for stability, because especially if you have a lot of PCIe add-in cards that demand a lot of power. You can use up to 75 watts per PCIe slot, and the 5 Gen 4 X16 slots are sort of designed with that in mind. So you could run 4 GPUs on this thing, each using 75 watts, which is going to be an extra 300 watts of 12-volt power draw from the 12-volt rail through the motherboard. Not the PCIe power. Something to keep in mind, something to consider as you're building this. Get the older Fusion IO drives, like the one that I recovered. Yeah, those can also use 75 watts, so fun times. Also want to call special attention to the right angle audio connector at the bottom edge of the motherboard. If you are going to use this in a case like the Fractal Define XL2 or the Fractal Define XL cases that have that 8th slot at the bottom, so you could have a double slot card there, your audio cable is not going to block. There's a 30-pin USB cable there that may be a little problematic, but it's nice that they put the right angle audio connector in. Good job, ASRock. Oh yeah, I almost forgot, CPU selection. So OEMs have, I think, an 8 and a 16 core, but really at retail you've got the 24 to the 32 and the 64 core. The 24 core doesn't make any sense to me. Okay, let's assume it's $100 per core, $2,400 is a lot more, $2,500 is a lot more attractive than $3,200, $3,300 for the 24 versus the 32 core. You get the same number of chiplets, get just as much cash. That can make sense, but consider the whole price of the system. The motherboard, $1,000, a little less, give or take. 512 gigabytes of memory. 512 gigabytes of memory is not cheap these days. I mean, you could go 256 gigabytes, but if you're doing a build like this, you probably need 256 gigabytes, or 512 gigabytes, or a terabyte. The AM5 platform, I mean, is it still going to be limited to 128 gigabytes? I don't know, but you can run 128 gigabytes on a desktop platform. Is it PCIe, or is why you're here PCI Express? Okay. If you come at this from a different angle, there are P-series EPYC processors, AMD EPYC, for server. Yeah, it's not going to have the clock speed, but if you're coming at this for PCIe lanes, you really should look at what AMD has in the P-series EPYC lineup. The P-series are special processors that are one socket only, and they're sold at a discount. The 7402P, solved a lot of problems for me internally. It's a 24 core, it's very reasonably priced. There are Milan versions of that. That's the Rome version, so that's older. But you know, those 24 core, 32 core P-series CPUs, yes, in reality, they're probably going to be half as fast because the clock speed is so much lower on those EPYC processors versus something like Threadripper Pro. And the Threadripper Pro motherboards do have more features, but the motherboard cost is about the same. So if the only reason you're coming to this platform is memory capacity or PCIe lanes, you should look at EPYC. You could probably save a few $1,000s. If you look at the whole system cost for WRX80, because it's otherwise a good fit for what you're doing, the cost difference between 32 cores and 24 cores is negligible when you consider the entire system. And the 32 core system is going to have a lot more legs than the 24 core system. Honestly, a little bit surprised we don't see a 48 core Threadripper Pro, because I think that's where things would sort of slot in terms of, well, it's not $6,400, but it would be nice to have the additional cache and everything else, because, you know, it's 8 chiplets as opposed to 4 chiplets, but it's 2 times 24 for 48 as opposed to 24. Now, 24 can make sense for some of those edge cases, but consider the whole cost of the system and consider the relatively negligible cost difference between 24 and 32 cores. Do you really need 24 cores? This is my absolutely amazing Threadripper 32 core system. It's nuts. It's completely nuts. I did the wood grain myself. This is an upgrade from the 32 core 3970X, which I've actually put another fractal case back there, but I'll show you that in a minute. Yeah, I haven't put the EVGA 3090 Ti on a block yet. We've got the EK quick disconnect wood grain. I don't know, I like wood grain. The quick disconnect stuff is really awesome. So I've got my CPU on 2 360mm radiators plus a U.2 bay in the front. So I can add and remove U.2 devices to my system as needed. PCI Express 4 is a little bit of a challenge, still working on that. ICDock does have a PCI Express 4 compatible adapter, but it really only works with one particular Broadcom HBA. At least it works best with that one, and it's a little tricky to get everything just right with that. That's probably a video for another day. But this is configured with 512 gigabytes of memory, and this case has enough airflow to keep the memory cool and all that. You see, when you've got 512 gigabytes of memory, or a terabyte of memory, or 2 terabytes of memory as this platform supports, it uses a non-trivial amount of power, and it generates a lot of heat. It's basically a server. That's why the socket is turned this way, so that these things will get more airflow. Everything about this really kind of reeks server. I've got a triple slot GPU in here, but ultimately on a block for a single slot, that frees it up so that I could use all 7 slots as I need to, which has been the case With this, I could sort of, you know, if I really wanted to, I could stuff another device in there. Because this used to be a 3-slot 2080 Ti, now it's not. I've also got my U.2 in the bottom with my 3D printed adapter and the ASRock Creator WRX80 motherboard in this. Even running the 700 watt test loads with this configuration did great. Normally you'll also find a Tesla V100 in here for machine learning. This is what we ran that DALL-E Mini and some other things like that on. And again, with the EK quick disconnect fittings, works well. And I've got my kilowatt meter hooked up to the Threadripper Pro so we can do benchmarks and fun stuff like that. I've actually got another version of this that does data logging, but this one's useful for B-roll because the screen's a little bigger. What? 56,000! So that's where my build is right now, and I'm really happy with it. But let's talk, you know, DIY. Are you really, you know, it's $100 per core. Are you really going to DIY this? The 32 core is $3,200, and I think that's the one that you would DIY with this board. You can run the 64 core here, but when I was doing testing with this motherboard with the 32 core, the total system load in the system that I was testing without stressing the GPU was over 700 watts. 700 watts in the configuration that I just showed you with PBO and all the fixins and all of that. This motherboard, when I'm measuring the 12 volt rail, like the 12 volt rail draw from the power supply for the CPU, it is like 500 watts for the CPU, and like it'll back off to 400, 450 eventually. There are 2 fans for the VRM. The VRM is a 100 amp stage VRM. If you look at other motherboards, it looks like other motherboards have more VRM phases and more VRM configuration and blah, blah, blah. Okay, but you can't do anything with those phases. With this one, you can actually run PBO and you can actually do some of the other stuff. It's crazy to me that there are motherboards that have 73 power phases, but you can't let the CPU consume 500 watts. When you let the 32 core consume that much power, it's very close in performance to the 64 core. Now the stability might be completely out the window. And I think if you're spending $3,000 on a CPU, you're probably a little bit worried about stability. This is probably a machine that you're using for work. It probably doesn't make sense to overclock it or do anything with that. And to that end, that's why I recommend the registered error correcting DDR4 memory. If you are going to overclock it and you don't care and you're that much of an enthusiast that you're building it, go for the desktop memory. Get a real low CL rated desktop memory. Juice it as far as you can and probably enjoy being at the very top of all the leaderboards for all the benchmarks that you can do. It's pretty nuts. It's completely nuts. But hey, you do you. For creative and multi-core workloads, you know, the 32 core and the 64 core, they are unchallenged. Completely unchallenged at this point. The 32 core is 128 megs total of L3 cache because it's 4 chiplets. The 64 core is all 8 chiplets. It's 8 core chiplets, 64 cores. That's how that works. So if you have something that's lightly threaded but benefits from having twice the cache, it may actually make sense to buy the 64 core even if your thing's not really going to use all 64 cores. It just depends on the workload. And it's still cheaper than the 64 core EPYC equivalents, so if you only need a single socket, well, maybe you want to do that. And it's a much, much higher clock speed. I mean, look at the world record AMD EPYC server holder. It was 115, 112,000, something like that, in Cinebench R23. And Cinebench is, you know, admittedly something that scales uncharacteristically well for multi-core. On this thing, I can do like 56,000 at most with PBO and some tuning and some other knobs and things that have been fiddled, but like 56,000 with 32 cores. That's 1/4 the number of cores on the world record holder, and I get halfway there. A quarter of the cores, half the score. That's basically where we're at when you enable PBO. And the real head scratcher here was that when I just enabled PBO without fiddling with it, to just let PBO, the algorithm, do its own thing, which is technically PBO2. So I'm running PBO2 here. Just letting this motherboard manage the power and lie to the CPU a little bit and just letting it do its own thing without asking it to do the curve optimizer or well, I guess the curve optimizer is sort of a component there, but not artificially really juicing the CPU, just sort of letting it go on auto. I didn't actually experience stability issues, which is disturbing. Now, I was cooling it with the fancy custom loop, but I didn't experience stability issues with PBO. which is very weird because I've definitely experienced stability issues with PBO on the 3970X non-pro that I was rocking before. Huh. I don't know what to make of that. That's going to require some more long-term testing. This is the only board that I have that can do PBO, and it's shockingly good. Shockingly good. So if you're going to do a DIY system and you don't mind that, you're handling a $3,000 CPU, you're a wizard, you know what you're doing, then yeah, this motherboard makes a lot of sense as a platform for you, I think, for PBO. Although maybe you shouldn't PBO, or you should only PBO a little bit, or you shouldn't, do anything too awfully crazy. If you've got a tower cooler or anything other than a custom loop, I don't think it's sufficient cooling. I think, especially if you're going to do the PBO thing, just forget about it. It's not going to happen unless Ice Giant comes out with their horizontal socket thing. The Ice Giant cooler would do fine in a desktop configuration, but on a tower configuration. If you want to do a desktop configuration with Ice Giant in like one of the fractal cases, probably 3D printable feet that lets you set up the fractal case long ways instead of tall ways. Maybe that should be a thing in the level 1 forum. I don't know. But this launch has been weird because Threadripper Pro has been out for a while, but now you can buy them retail and you can buy boards retail, and they're pretty expensive. But if you use these for work, it's in line with what CPUs cost for workstations. So it's not really out of line. It's out of line if you're an enthusiast. And it's not out of line if you're spending this to make money or make your business money or make your clients money or whatever it happens to be. Oh, and yeah, it does have polychrome RGB if you want to go crazy with your RGB-ness and all that stuff. You got polychrome, 50/50 headers, digital headers, the whole 9 yards. So overall, good job ASRock. I am proud to be rocking this system in my daily driver workstation for the next ever, who knows how long. 512 gigabytes of memory is nothing to sneeze at. And Linux works like a dream on this. I can't say enough good things here. It's awesome. I'm Windowless Level 1. This has been a quick look at the WRX80 Creator. If you're going to embark on the Threadripper Nation, your build and everything else, join us in the Level 1 forums because there's some hard-won lessons there from prior generation Threadripper builds. There's a lot of esoteric peripherals there that a lot of people are rocking, and we figured out a lot of the weird stuff. Join us. All right, I'm signing out, and I'll see you there.